Here's the average pressure loss calculation that needs to be done. We're just going to go through an example here. Again, this table is in the appendix and it's very simple to use. So we'll just say, for example, there's 100 psi available at the property line, which will convert to kPa. So remember, 1 psi is equal to 7 kPa for design purposes. And we'll just say that we're going to lose 100 kPa, grabbing a random number there, through the service. Could be a little bit of elevation loss, maybe a few fittings that we incur. So we'll say that there's 100 kPa lost and that we're able to get 600 kPa to the building, and we'll carry that down here. So our adjusted pressure, what's available to the building, is 600 kPa. We'll assume we have a PRV set to 550. So if we have 600 kPa coming into the building and we have a PRV set to 550 kPa, we would have a pressure loss of 50 kPa. Deduct 50 kPa there. Losses for system height. So assuming we have, we'll call it 3 meters of system height, the calculation to do there is 10 kPa per meter of head. So we're going to lose 30 kPa just to lift the water. The minimum pressure available, or minimum pressure necessary, for fixture operation is typically taken at 105 kPa minimum. That's 15 psi, and that really is a bare minimum. Most residents, most people that use fixtures, shower head for example, would usually expect or anticipate, have an expectation, let's say, of more than 15 psi for satisfactory fixture operation. As a design minimum, 15 psi will work in our case. So once we subtract all these losses from 600 kPa, we get 415 kPa available. That's what's available for friction loss to the piping. So we're going to carry that down here to the next line, 415. The developed length of our system we'll say is 60 meters. Developed length. And we need to multiply that by 1.5. So we're going to increase it by 50%. 60 times 1.5 is 90 meters. So again, just to be clear, 60 meters was our imaginary developed length, but 90 meters will be our actual equivalent length. So we're going to divide the pressure that's left over after we calculated our losses due to devices and elevation. Divide it by the equivalent length of the system, and we come up with 4.61, which is kPa per meter. So that's what's available per meter of our system, or at least the equivalent length of our system, to be lost to friction. As long as we exceed 2.6 kPa per meter, then the average pressure loss method can be used, the table can be used. If we're doing the calculation in psi and feet, then the minimum is 0.115 psi per foot available. If these minimums aren't met, then a detailed engineered calculation would need to be performed.